In 2026, laptops changed more than raw speed. New hardware and software designs prioritize local AI, energy efficiency, and sustained real-world performance. This video breaks down the differences across design, processors, displays, connectivity, and software with crisp benchmarks and real comparisons. Expect on-screen spec overlays, split-screen comparisons, close-up supports and keyboards, and concise bullet highlights to make choices simple and evidence-based. At the center are three core changes: dedicated neural accelerators, smarter power chemistry, and displays that cut energy use while raising brightness and color fidelity. We'll quantify those gains with benchmark charts comparing CPU, GPU, thermal behavior, and battery drain under real workloads. By the end, you'll know which features matter for creators, professionals, and mobile users, and how 2026 models differ from prior generations. Material choices shifted. Magnesium alloys, recycled graphene laminates, and precision CNC still dominate, but with lighter overall weight and higher stiffness. Manufacturing tolerances improved, visible and uniform gaps, refined hinge mechanics, and consistent panel fit, all indicators of premium durability. Hinges evolved for multi-angle workflows, including flat lay modes and low-profile stands while maintaining airflow pathways for cooling. Keyboards favor lower travel with force-sensing keys and per-key haptic feedback that mimics deeper travel without added thickness. Port layouts standardize around USB 4 and Thunderbolt 5 plus MagSafe style connectors. Many models also include user-serviceable expansion modules. Look for water-resistant seals, repaired-friendly internals, and recycled materials as signals of long-term value and sustainability leadership. 2026 CPU architectures mix high-performance cores with many efficiency cores and integrated neural processing units for local AI acceleration. Dedicated NPUs perform image and voice inference on device, reducing latency and protecting data by keeping models off the cloud when desired. Benchmarks now report NPU throughput and efficiency alongside CPU and GPU numbers. These metrics often matter more for everyday AI tasks. Thermals use vapor chambers and directed heat spread plates to maintain sustained power without dramatic fan noise or throttling spikes. Real-world tests show improved sustained multi-thread performance and better AI task completion per watt compared with prior generations. Split-screen comparisons highlight how NPU-enabled models complete image processing and transcription tasks far faster while using less battery power. Displays moved beyond OLED. Micro-LED and advanced mini-LED panels offer higher sustained brightness and improved color volume with lower energy draw. Variable refresh and per-pixel modulation adjust power dynamically, saving battery during static work and scaling for creative or gaming scenes. Touchpads evolved with haptic zones and adaptive resistance for realistic feedback, while stylus latency fell below perceptible thresholds for artists. Microphone arrays paired with on-device AI deliver beamforming and noise suppression that outperforms many external solutions for remote work. Speaker systems use front-firing arrays and tuned enclosures to create fuller sound without adding significant thickness to the chassis. On-screen spec overlays will show peak brightness, color coverage, response time, and measured battery impact to help you compare displays at a glance. Connectivity standards advanced. Wi-Fi 7 and multi-link connections reduce latency and allow parallel streams for cloud sync and local AI offload. Security improved through hardware roots of trust, secure enclaves, and on-device biometric AI that protects private models and personal data. OS-level AI assistants provide context-aware suggestions, live translation, and summarization while giving users explicit privacy control over model data. When choosing a 2026 laptop, prioritize NPU capability for your workflows, display quality for creatives, and battery chemistry for mobile professionals. We present concise bullet highlights and a final split-screen ranking that summarizes performance, battery life, display quality, and value for money. In short, the best laptops of 2026 combine specialized AI hardware, efficient power systems, advanced displays, and integrated software for materially different experiences. Top laptops combine hardware and software to keep your data safe. They use biometric logins, isolated security chips, secure boot processes, and built-in encryption. The result is a layered defense that prevents unauthorized access, thwarts firmware and supply chain attacks, and maintains data confidentiality even if the device is lost or stolen. We'll cover biometrics, secure enclaves, and TPM 2.0, secure boot and firmware updates, full disk encryption, and vendor security suites. These features often work together. Biometric authentication unlocks keys stored in a secure enclave, which in turn enables encrypted storage and trusted booting of firmware. Expect manufacturers to ship signed firmware updates, measured boot chains, and analytics to flag suspicious behavior while allowing enterprises to enforce policies centrally. By the end of this overview, you'll understand how modern laptops defend your data and how to evaluate devices for real-world protection needs. Biometric authentication uses fingerprints or facial recognition to verify a user quickly and securely, replacing or complementing passwords for faster, phishing-resistant logins. The best implementations perform biometric matching entirely inside a secure enclave or trusted processor, so raw biometric templates never leave the device or cloud. Hardware sensors vary. Optical and ultrasonic fingerprint readers, and infrared or depth cameras for face recognition. Sensor quality matters for reliability and spoof resistance. Look for devices certified under FIDO2 and Windows Hello or equivalent standards, which standardize secure biometric workflows across apps and browsers. Enable multi-factor authentication where possible. Combining biometrics with a PIN or hardware security key raises protection against sophisticated attacks. Enroll multiple fingerprints and keep recovery methods updated in case of sensor failures or hardware repairs to avoid lockouts and maintain access. Secure enclaves and TPM 2.0 are dedicated hardware components that isolate cryptographic keys and critical processes from the operating system and applications. Keys for disk encryption, biometric matching, and device attestation are generated and stored inside these chips, reducing the risk of key extraction by attackers. TPM provides attestation. It proves to software or remote services that boot and firmware are in a trusted state before sensitive keys are released. Secure Boot validates firmware signatures at startup, blocking unauthorized or tampered firmware from executing and stopping persistent low-level attacks. Measured or verified boot records, cryptographic hashes of boot components, so changes can be detected and reported to management consoles or security services. Firmware updates must be signed and delivered through trusted channels. Prefer automatic vendor-signed patches and verify update integrity before applying. Full disk encryption protects data at rest by encrypting the entire storage with keys only accessible to authorized hardware or boot processes. Modern laptops include hardware-accelerated AES and fast NVMe SSDs to maintain performance while encrypting everything transparently. Enterprises gain secure key escrow and recovery options that enable safe key management without weakening device-level protections. Vendor security suites bundle device management, threat detection, runtime protections, and secure update services to reduce operational risk. Look for sandboxing, exploit mitigations, behavior-based analytics, and integrated hardware-backed protections in vendor bundles for proactive defense. Balance convenience and control. Enable encryption and vendor protections while reviewing privacy and telemetry settings to match your risk tolerance. Best practices start with secure setup, enable secure boot, enroll biometrics, and activate full disk encryption during initial device configuration. Use a PIN fallback. Enable multi-factor authentication for accounts and register recovery options to avoid lockouts and improve account resilience. Device example 1, Ultrabook A, offers a fingerprint reader tied to a secure enclave, TPM 2.0, and automatic vendor-signed firmware updates. Device example 2, Convertible B, uses a depth camera for face unlock, hardware-backed encryption, and an integrated endpoint security suite for consumers. Device example 3, Developer Laptop C, includes a discrete TPM module, measured boot, and enterprise key escrow to support secure development workflows. Device example 4, Business Workstation D, adds a dedicated secure enclave, managed security services, and remote attestation for large deployments. Laptops are more powerful and under greater environmental scrutiny than ever for consumers. Today we examine materials, energy use, repairability, recycling, and eco-certifications using recent studies. We'll compare leading 2026 models and highlight measurable environmental differences and measurable metrics. This concise overview relies on published manufacturer data and independent testing and third-party sources. Expect on-screen statistics and short product shots to illustrate each point. Captions will show numbers. Let's begin with material sourcing and the footprint of components with clear benchmarks. Key materials include aluminum, magnesium, rare earth elements, and conflict minerals in common models. Aluminum reduces weight, but requires high energy for smelting, unless recycled content is used and less powered by renewables. Manufacturers reporting at least 30% recycled aluminum show lower cradle emissions, measured in kilograms of CO2. Rare earths and cobalt often come from regions with weak labor or environmental controls affecting environmental risk. Some brands publish supplier audits and traceability maps, improving sourcing transparency and public scorecards. Look for explicit recycled material percentages and supplier audit scores when evaluating models on spec sheets. Energy efficiency is measured by idle power, active power, and display energy consumption, and screen efficiency matters. In 2026, ARM-based and optimized x86 chips lead in performance per watt metrics, especially under light loads. Top models show 20 to 40% improvement in real-world battery life over 2023 equivalents, depending on usage patterns. Fast charging reduces charge cycles but can affect long-term battery health if unmanaged. Check manufacturer guidance. Manufacturers publishing watt-hour per charge and life cycle estimates enable apples-to-apples comparisons and independent lab reports. Choose models with adaptive power profiles and third-party testing verification for best efficiency prioritized in reviews. Repairability reduces life cycle impact by extending usable life and minimizing electronic waste where applicable. Modular designs, replaceable batteries, and standard screws improve repair scores significantly and accessible spare parts. Independent repairability ratings often correlate with lower total carbon footprint over 3 years across multiple models. End-of-life recycling depends on take-back programs, certified recyclers, and recoverable material rates and material recovery rates. Eco-labels like EBT, Energy Star, and EU EE Elocable provide standardized environmental claims but verify scope. Verify certification dates and scope, since label criteria evolve rapidly over time, and look for updates. Comparing top 2026 laptops, environmentally friendly choices balance recycled materials and energy efficiency based on life cycle data. Model A leads in recycled aluminum and repairability. Model B excels in energy per watt with quantified lab results. Model C offers certified circular takeback and verified supply chain audits, including parts recovery rates. Short on time, prioritize repairability, energy efficiency, and transparent material reporting and manufacturer warranties. When shopping, check independent test reports, certified labels, and manufacturer take back policies, and return logistics. Small choices add up. Extend device life, choose verified models, and recycle responsibly. Your choices influence demand.